Okay, so today's lecture is called Ions Pre-Review because we learned about ions, but it was like a long time ago, right? And so I wanted to refresh your memory a little bit. So don't copy all of this down. Again, you guys do not need to copy down everything for the notes. This is all posted on Canvas. I'm recording this for Canvas, so you'll have a video, but I'll let you know the important stuff to copy down, okay? So copy down the title. That way we know what lecture we are taking notes for. So let's write that down. Ions Pre-Review. All right, and so let's get started. So, hey guys, remember my one rule. Thank you. Okay, so we learned about ions. So you guys don't need to write this part down because it's review, and again, this is recorded, so you'll have a refresher. Ions are basically particles, so little objects that have an electronic charge. Basically, it just means if it's positive or negative. Like when you have a battery, right? One side is positive, one side is negative. And what we learned is that if you have two charges that are the same, so positive and positive, they're going to push each other away, okay? But if you have a positive and a negative, they're going to attract. So they're going to attract together and they're going to combine to form a new chemical. Okay, and so that's what we're going to be learning, about, okay? All right, so real quick about on the periodic table, I'm going to pass out a new type of periodic table. And so what I want you guys to do right now is just copy down number 1 for me right here. Okay, I know usually I don't have you guys copy down problems, but just so that while we're reviewing, I want you guys to copy down number 1. Okay, and we'll figure out how to answer it together. And while you're doing that, I will pass out the new handout. Disposable cups? No, I don't. Yeah, sorry. You guys should be copying down number 1. So there's a handout coming, so if you guys can take one, pass it down, I would appreciate that.
I need to take it on my foot. Oh my god. Yes. I need to take it clean foot. What? I never bring my tape. And turns would take no. When I get it,
Alrighty, guys. So hopefully you guys are finishing up copying down that problem. Once you guys finish copying that down, I will talk about the handout that you guys just got. So I'll give you another minute to copy it down. All right. Does anyone still need time to copy the question down? Okay. So if not, let's take a look at the handout that you guys just got. So let's look at the periodic table. Now, if you guys notice, it's pretty much the same thing that we've been working with, right? The only difference is if you guys notice on top of the columns, there should be a +1, +2, +3, and so on and so forth, right? Okay, now these numbers right here, these are called most common ions, okay? And most common ions are basically what ion or what, electronic energy these atoms want to get. So this is very easy to use. Basically, you just take a look at this column. If it is in the +1 column, these guys want to become +1, okay? So if I ask you what sodium's MCI is, okay, sodium wants to become sodium +1. Okay, super simple, right? If I ask you what nitrogen's MCI is, nitrogen wants to become -3. Okay, so on and so forth. If I ask you what oxygen wants to become, if you guys take a look on the top, oxygen wants to become -2. Okay, any questions about that? How to use that table? Okay, so with that in mind, let's take a look back at the problem you just wrote down. The question asks us to write the formula for the compound or the molecule that is made between these. So what I want you guys to do right now is take about 30 seconds or a minute. Let's look on the periodic table. Thank you. And I want you guys to write down what ion, what's the MCI for Ca and for F. Okay. So look on your periodic table and look up what does Ca want to become and what does F want to become. Okay. So take about a minute to do that, and then we'll double check. Again, look at the top of the column on your periodic table. You're going to be looking at Ca and F. Hello. You have a class right now? Huh? Okay. Alrighty, guys. So let's take a look at the periodic table. So we're looking at Ca and F. So if we take a look at the periodic table, Ca is right here. Okay. What's the MCI for Ca? Yeah, +2. So Ca is going to be +2. And then F is right here. And what's the MCI for F? -1. Okay, so you guys should have wrote Ca +2 and F -1. Yeah. That's just the way that we write it in chemistry. But if you write +2, that's totally fine too. Whatever you're more comfortable doing. Yeah, I'm not gonna be a stickler about that. Either way works. It's just that most people write it like this. But again, for this class, I don't mind if you do +2. It wouldn't be wrong or anything like that. Yeah. Just know what it means when I write it like that. Okay. Good question, of course. Okay, so these two are combining together. So if you guys take a look at this, it says that, or we found out that Ca is +2 and F is -1. And we talked about how positives and negatives, they like to come together, right? So they need to come closer together and they're going to attract and stick together. Now, what the problem here is that when these molecules or these particles come together, they want to be balanced with one another, right? It's like, if we take a look at this, this is +2 energy, right? And this is -1 energy. So do we have more positive energy or more negative energy? Yeah, we have too much positive energy. So like in a friend group, if you have that friend that's way too positive, right? Always super happy, even super early in the morning, it gets a little annoying, right? And so we need to balance that out with some sadness. We want to make it a little bit more negative. So what we're going to do is we're going to add negative energy until it balances out. So we have -1 right now. So if we add one more, how much negative energy do we have in total? 2, right? And now we are finally balancing out the positive energy and the negative energy. Okay, do you guys all see that? Okay, so what they're going to do is they're all going to come together and they are going to combine. And the molecule that they're going to make is going to be made out of 1 calcium, 1 Ca, and it's made out of 2 Fs. Okay, so 1 Ca and 2 Fs. So the answer here for this problem right here is going to be CaF2. And then if they're stuck together, we just put a 2 down here on the bottom right. Okay. So that's it. That's what we'll be doing today. We'll just be kind of balancing out the positive and the negative energy and seeing what molecules that we can make. All right. Okay, let's try one more together and then we got a few more practice problems after that. So I'll give you guys another minute. I want you guys to take a look at your periodic table and figure out Li's most common ion and then oxygen's MCI. Okay, so same thing we just did. Take a look at the numbers on the top of the column. See if you guys can figure out the most common ion for Li and for O. Okay, take about a minute to do that. And if you think you could put them together, try it out. If not, we'll go over that in just a second. Take a minute to find their MCIs. So if we take a look at Li, Li is right here in this column. What's Li's MCI? +1, good. And then oxygen is right here. What's oxygen's MCI? -2, exactly. Good job, guys. So we got Li, which is +1. And we got oxygen, which is -2. Okay, so if we take a look at this time we have way too much negative energy, right? So how many Li's do we need in total in order to balance it out? Yeah, we're gonna need 2, right? If you guys notice, you're gonna need 2 of these to balance out the -2 right here. So if they all come together to make one compound, we're going to write down Li. And since we have 2 of them, we just put a 2 underneath it. And then since we have 1 oxygen, we just write an O right there. And there you go. That's what we will get for our final answer. Li2O. Okay. Any questions about that? Hopefully it's not too bad. Okay, so we're gonna be adding one small thing on top of this. It's nothing really is changing. We're just gonna be looking at some different types of ions. So if you guys notice, we've been looking at ions with just one atom, right? One element on the periodic table, like Ca, F. Now, but there's these other things called polyatomic ions. Now, you guys don't need to write this down, but if you take a look on the back side of the periodic table, you should see a handout that looks like this. You guys see that on the back? Okay. Now, if we take a look at the top half, we're not going to look at the naming part yet. Okay, there are these formulas right here, and these guys are called polyatomic ions. Basically, these are molecules that have a positive or negative energy. And the important thing about these guys is that they stay together. Okay, so this I'm gonna make it as easy as possible for you guys. If you ever write down these polyatomic ions, just copy them down exactly the way that they are. Okay, don't change anything about them. Just copy it exactly the way you see it on the handout, okay? So these work exactly the same thing as regular ions. If you guys notice, they have a +1 energy, -2 energy. It's the exact same thing. The only difference is that they're just a group of atoms, and you just copy them down exactly the way they are, okay? So let's try out one problem together, and I'll see if you guys can try another one on your own, okay? Okay, so here we're going to be combining SR, MCI, and carbonate. Okay, so SR and carbonate. So let's go to the periodic table. If you take a look at SR, SR is right here. So what's the MCI for SR? +2, exactly. Okay, so SR is +2. Okay, next we got carbonate, and if you look, there's no carbonate on the periodic table, but we have a carbonate on the polyatomic chart, right? So we're just gonna copy down carbonate exactly the way it is. So CO3 2-. Okay. All right, so if you guys take a look at this, are they balanced out? Yeah, this one's +2, this one's -2. So this one's really easy. All we got to do for our final answer is just put them right next to each other. And that's it. This will be our final answer. Okay, so it's pretty much the exact same thing that we were doing. All we're doing is making sure the charges are balanced out. Okay. And again, if you notice, we just copy it exactly the way it is on this table. Okay, we'll do one last practice problem. I know there's 5 and 6. We won't do those. And then I'll get you guys started on your assignment, okay? All right, so last one. We got BA's MCI and hydroxide. So what I'm going to do is I'm going to give you guys BA. BA is +2. Okay, and then the anion is hydroxide. Hydroxide is right here. And if you notice, that's me. It's OH. OH-. Okay, that's my favorite polyatomic ion. Okay, so if we take a look at this, which one do we need more of? Do we need more BA or hydroxide? Yeah, obviously hydroxide. So we're going to need 2 in total, right? Because that's going to give us -2 to balance out the +2. Okay, so we're going to put them together now. So these are all going to combine. So what you're going to do, and I think this is the easiest way to do it, is just write the 2 ions next to each other. Okay, don't worry about how many there are. Just put them right next to each other. Okay, now we only need one BA, so we can just leave it alone. But we need 2 hydroxides, right? And like I said, we don't want to change anything about them. So what we're going to do is, since we need 2 of this, we're going to put it in parentheses to just kind of keep them together. And since we have 2, we just put a 2 on the outside. Okay, and that's how you write down multiple polyatomics. Again, copy it down exactly the way it is, and then just put parentheses around it and put however many you need on the outside. Okay. And that's pretty much it. Yes.
How many put parentheses
On this one, the BA, because we only need 1 of them.
No,
Oh, this one right here? Yeah, because we only need 1. Yeah, if you only need 1, you can just ignore the parentheses. Yeah, I mean, if you put parentheses, I won't take off points, but you don't need to if there's only 1. Okay, good question. Alrighty, so I'll give you guys the rest of the class period to work on your assignment for this.